Hello all. In this video, we are going to explore the keypair.seed method that we covered in the last video. And here we are just going to do a lot of console log and see what is going underneath. Last video we just skimmed over, so a high level idea and got the result. Here we are going to see what all are we using and what all do these objects look like and how do they get transformed. Yeah. So moving on. So I'll not be doing any typing in this video. All the code that there is this 23 lines. So it's already typed out. We'll just run the code. Let's just run it first. It's yarn ts node helpers dot testing to mnemonics.ts, and it's in local. We are inside local, so just run it. We see a bunch of things that have been console logged here. We see a seed trace, we see seed trace byte, we see seed derived path, and we see seed trace byte, we see seed derived path, we see seed derived path key. We see uint8 representation of seed derived path, and then we see keypair from seed, which is a keypair object. Now let's just I'll just show you one thing here and then we'll go to the code and we'll start understanding. Just look at this part of this object, uint representation of seed derived path. It's a uint8 array with 32 elements, and here I'll just enlarge this a little bit so we can see what I'm pointing at. Here it's 189, 200, 145, so on and so on, and it happens to match the secret key's initial 32 bits. And we know the final 32 bits are 169, 103 up till 186. We can see it here. Let's find it. 169 here. So 169 and ends with 186. That is the public key. And here 189 and ends with 173. And here we see 189 and ends with 173, and after that starts the 169. So we see something matching here. Last time we saw that the last 32 bits matched of the public key matched the last 32 bits of the private key. Here we are seeing the same about the first 32 bits. So we shall see what that is, how we are getting it in the code. I'll minimize this one and we shall see. Here the first three lines are imports. We talked about this and this are the new imports that help us do this. Now let's talk about the BIP39. Here before that, this is a path constant. This is called the derivation path as per the documentation. I am not going to talk a lot about this, but this 501 here points to the Solana network, and we can change this 0 over here to 1, 2, 3 and so on, and we are going to get different keys by changing this. And each time if we keep using 0 and if we keep the other things same, then we are going to deterministically create the same key pair. So that is what it is. I'll explain what deterministically means in a while, but let's see what we were console logging. Let's read this comment. Generate a seed trace of 12 words default. So the BIP39 generate mnemonics generates by default a string of words, string of 12 words by default. We could change it, we could provide it some number, and it shall generate different lengths of the string, but for our purpose we don't really need that. Where do we use these seeds? We talked about last time. When we create a wallet account on Phantom or Backpack or some of the wallet providers, we generally get these seed phrases which the wallet interface asks you to save so that you can use it to generate the key pair or sign in again in case you want to from a different device. So moving on, and that is how uh, that is how the seed phrase looks. By the way, the seed phrase is not just uh, a collection of random words. These words come from a particular set, and you can read about where the seed phrase, where the mnemonics come from. It is a fixed set of words which are uniquely identifiable, and if you read upon it, you will find more interesting stuff. But if you're just a beginner and you don't want to beat your head a lot around it, then we can just move on. Now we generate this 12 word seed phrase, and then we give it to mnemonic to seed sync. This also comes from BIP39. It takes those words and it converts them into bytes, into their byte form, and we are console logging both of them. We are console logging the seed phrase and the seed phrase byte. We'll see the console log again after we discuss this. Here we do generate Solana compatible seed from the mnemonic seed phrase. Here we are using the derive path method that we imported here, derive paths from ed25519 hd keys, and what we are doing here is providing it the path, providing it the seed phrase byte, not the seed phrase, the seed phrase byte, and we are converting the seed phrase byte into a string, and we are then converting into the string into its hex format, the byte to string to hex. And this is what I'll just hover over it. This is what it expects. We saw that in the last video, and then we are using the dot key to get the key out of it. The next thing that we are next constant you see here is uint8 seed derived path key. So we get the seed derived path key. This is the uint8 representation of the same. So we are just, all we are doing is new uint8 array seed derived path key, only for the purpose of console logging and seeing what it does. So here what we are doing is seed derived path console logging. The first thing we are doing is console logging the seed derived path. The difference between this line 16, and what we are console logging here is that this doesn't have the dot key, so we get to see the actual object from on which we are applying the dot key method. The next line 19, is console logging seed derived path key. This is exactly what we got here, this one in line 16, and the next one is a uint8 representation of the seed derived path key. So we shall see what is the difference. This is the whole object, this is the key from that object, and this is the key converted into uint8 array. The next line here is generate Keypair. This is the given method from Keypair class. It takes this seed derived path key object. Let's look at it. The type it expects. It expects a uint8 array buffer like, and it gives out a key pair. We are catching the key pair in Keypair from seed, and that is what we are console logging here. So let's look at this one again. So first we see the seed phrase, then we see the seed phrase bytes. You can see it has been converted into bytes and it's in a hex form, and there are 14 more bytes that are not displayed here. Then there is the seed derived path object. It has key and chain code. Look at this. This is the key, and seed derived path key is this same exact object, BCC89155. BCC89158. We are ignoring the chain code because we do not need that one. This happens to have 32 bytes over here. So when we convert this into a uint8 array, it becomes a uint8 array of 32 bytes. And as you know, we compared this object to the initial part of the secret key. It is the uint8 representation of the seed derived path key, not the path. It should be seed derived path key. And you see the match here. It matches the first 32 bits of the secret key, 189, as you saw. And that is how you generate the key pair from seeds. In the next video, we'll be exploring how to save the generated mnemonics in our file system and get it, and then once we manage to do that, this time what we are doing, we are generating a mnemonic each time we run the code, and hence each time we run the code we are going to get a different key pair. But if we manage to get the same mnemonic or same seed phrase, then we will manage to get the same exact key pair, and that is necessary, and that is why wallets provide you with the seed, so that you can generate the same key pair. So if you have some balance somewhere, you will be able to access that. So we'll do that in the next video. Thank you.